here's our vocabulary. Measures of central tendency are mean, median, and mode. They are ways of measuring the center of the data. Measures of spread are ways of measuring how spread out the data is. So that would be range, interquartile range, and standard deviation. An outlier is a data value that is much greater or less than the values in a data set. Outliers can affect certain measures of central tendency and spread and give a false idea about a data set. The range of a data set is the difference between the greatest and the least value, so that would be max minus min. An interquartile range of a data set is the difference between the upper and lower quartile. And the new word for today is standard deviation. It is a measure of how the values in a data set vary or deviate from the mean. The mean is the sum of the values divided by the total number of values, and it's often referred to as the average. So we use the mean to describe the middle of a set of data that does not have an outlier. So it does not have an outlier. The median is a value in the middle, and that's what we use with our box and whiskers. For a set of data containing an even number of values, the median is the middle of two middle data values, so then you have to calculate the average. We use the median to describe the middle of a set of data that does have an outlier. The mode is a data set item that occurs the most times. A data set can have no mode, one mode, or more than one mode. We use the mode when the data are numeric or when choosing the most popular item. Bowling. What are the mean, median, and mode of the bowling scores below? Which central tendency measure best describes the scores? So there's 4 bowlers over here and there's 8 bowlers over here, so we have a total of 8 scores. So to find the mean, we're going to add them all together and divide by 8. So our average is 122, and sometimes that's called X bar. So that would be how you abbreviate the mean. The median would be the middle number, so we have to put them in order. So again, I have 8 numbers, so that's going to be the middle between 109 and 113, so we have to average them. So you add them and divide by 2, and you get 111. The mode is the most occurring, so 104 happens the most, so that would be the mode. Because there is an outlier of 189, the median is the best measure to describe the scores. The mean 122 is greater than most of the scores. So, and the mode 104 is the lowest score. So neither the mean nor the mode describes the data very well. The median best describes the data because that 111 is kind of in the middle here, whereas the 122 is more here and the 104 is way here at the bottom. Finding the measures of spread. What is the range of each data set? What is the interquartile range, and what do these ranges tell you? So for Miami, so I'll call that MI, the range is, it looks to be about 8.6, and then over here this is about 1.7. So I did 8.6 minus 1.7, which gives me a range of 6.9. And then for New Orleans, we have about 6.8 and 2.9. So 6.8 minus 2.9, throw that on the calculator and you should be getting 3.9. So again, for Miami, the interquartile range, so I'm looking for Q3 and Q1. So Q3 is 7.3 and Q1 is 2.3. So 7.3 minus 2.3 for 5. For New Orleans, we're looking at 6 and about 4.9. So 6 minus 4.9 gives us 1.1. What do these ranges tell you about the data? New Orleans has more consistent rainfall. Miami is very variable. The next thing we're going to look at is standard deviation. So the Greek letter sigma represents the standard deviation. So what I like to do is draw a 0 and then just kind of loop it over. and it should be more of a straight loop. So that's sigma, so that represents standard deviation. We're not going to go too heavy into the formula, but if you ever take a statistics class, you will need to know these symbols. So the first step is you have to find your mean, and again, that's your x bar. And then the second step is to find the difference between each data value. So here is our data. And then notice the mean is the same every time. And then what we're going to do, step 2 says calculate the difference. So then I do 12.6 minus 15, 15.1 minus 15. So this is the difference. So I'm just subtracting those numbers. And then here, I take the number over here, and then I just square it. So when I square each of these numbers, it should be positive. And then down here, this sigma, that Greek symbol stands for sigma, so that's the sum. So you add all these together, and then you divide by the number of numbers that you have. And then down here, this is where you actually take the square root of that number, and that's where you get your standard deviation. So let's practice that. So here's our data set. So we have to calculate the mean and the standard deviation. So what we need to do is calculate our mean, and we'll use our graphing calculators for that. So please go to your home menu, and then I want you to hit Stat, Enter. So notice how I have some numbers in the column. So if I hover over the list name, so see if I just push over, I can hover over here and you hit Clear, Enter, and it will clear all the data in that list. So make sure your lists are cleared out, and now we're just going to type in our numbers from data set 1. 102, 98, 103, 86, 101, and 110. So there should be 6 numbers in your list. Notice that 6 right there. And while we're here, we'll get the second data set in there also. So I just pushed over, and I'm in list 2. Make sure it's clear, so hit Clear, Enter. And now I can type in my list 2. 90, 89, 100, 97, 102, 97. So I have 2 sets of data, and each of them have 6 numbers in each list. So go ahead and hit second quit and go to your home screen. So remember, what we're trying to do is we're taking this data set, we have to calculate our mean, and then we're going to fill in this table. So if you go Stat, over to Calculate, so I hit over, and I want number 1, variable stats, and I hit Enter. And what I want to do is find variable stats for the first list. So see in the blue above number 1, I'm going to hit second number 1, and that shows me list 1. So that was second 1, and then I hit Enter. And there's my X bar, and then down here is my sigma, so that is my standard deviation. So now I need to fill in my table. I have my X bar, and my X bar is the same for all of the data. So my X bar, we said, was 100. So I'm just going to type in 100 on each one of these. And then I need to calculate the difference from the mean. So I'm doing 102 minus 100, 98 minus 100, 103 minus 100, and then the next column, I'm going to take that number and square it. 4, 4, 9, 196, 1, 100. And then the next column, I add these up and I divide by 6, and I've already had that calculated, and I get 314 is my sum, and then I have to divide that by 6, so that gives me the 52.3. And then I take the square root of that number, and that gives me 7.23. So that's how you calculate standard deviation by hand. And notice how that number is the same thing on the calculator. But we are going to just use the calculators. We're not actually going to do those by hand. So let's skip that second data set. So with that standard deviation, what we're assuming is that all of our data falls under this bell curve. So this is at our X bar. And this would be 1 standard deviation away, 2 standard deviations away, 3 standard deviations away. and we'll talk more about this as we get going, but notice within one standard deviation, so from here or one standard deviation below, from here to here, that is 68% of the data. Then if we go 2 standard deviations away, that's going to be about 95% of the data, and you could calculate the rest for 3 standard deviations away and so on. So here are some data. This would be where our X bar is, and then you could figure out this is 1 standard deviation away, 2 standard deviations away, and so on. What is standard deviation? Standard deviation is a measure of how spread out the numbers are, how far from the normal the numbers are. Figuring out standard deviation is tedious, it takes a long time, and is not that fun. Example, the average test score on the 9th grade English test was an 87. The standard deviation was 3. Fill in the chart with X bar plus 1 standard deviation, and so on. So if we want to fill in this chart, we know that our average was 87. Then if we go 1 standard deviation away, we're just going to add 3. 2 away, add 3. 3 away, add 3 more. So then to go the other way, we subtract, subtract, subtract. So what we find out is that between an 84 and a 90%, 68% of the people should have their test scores within that standard deviation. From an 81% to a 93%, that's where we get the 95% of our data. Standard deviation is a statistic that tells you how tightly all the various examples are clustered around the mean in a set of data. When the examples are pretty tightly bunched together and the bell curve is steep, the standard deviation is small. So that would look something like this. So then our standard deviation is going to be small. When the examples are spread out and the bell curve is relatively flat, that tells you that your standard deviation is going to be large. So let's look at a question. The average IQ of students in Gustafson's geometry class is 115, with a standard deviation of 5. The distribution is roughly bell-shaped. Label the curve below to represent your standard deviation. So see if you can fill this out on your own. This is what your solution should look like. Try another one. With an X bar of 117, we can add a standard deviation of 3 every time, and then on the left side we're subtracting 3. What does standard deviation look like? Suppose your data follows the classic bell-shaped curve pattern. Think of standard deviation as a measure of how spread out the curve is. Shown below is a bell curve and a bar graph with a standard deviation of 1. Notice how tightly concentrated the distribution is. Most of the numbers are close to the middle. Some of the numbers are higher or lower, but most of them are close to the middle. So this is where your X bar is. So your average is about 0. And over here it tells you your mean is 2.56, so that would be somewhere in here. And notice it does kind of follow that bell-shaped curve. This bell-shaped curve and bar graph has a standard deviation of 2. The curve is wider, which implies the data are less concentrated and more spread out. More numbers are higher or lower than the middle. So again, more spread out. Here's our X bar, 3.38. Here's our X bar, so there's more data spread out. Finally, a bell-shaped curve and a bar graph with a standard deviation of 3 appears below. This curve shows the most spread. Even more of the numbers are higher or lower than the middle. So again, X bar is still the same. Data is spread out. X bar here is 5.86. And then notice we have more gaps and there is more distribution of data. How can the bell curve help us understand standard deviation? One standard deviation away from the mean in either direction on the horizontal axis accounts for somewhere around 68% of the people in this group. So in that blue region, that's going to be 68% because we're 1 standard deviation away. 2 standard deviations away from the mean account for roughly 95% of the people. So from here to here, that's going to be 95%. And 3 standard deviations away, that's where you're looking at 99% of the people. If the curve were flattened and more spread out, the standard deviation would have to be larger in order to account for those 68% of the people. So that's why the standard deviation can tell you how spread out examples in a set are from the mean. So let's get to example 2. Calculate the mean and standard deviation of the following list of end game scores for a football team. So I need to grab my graphing calculator, and on my screen I have some stuff, so I need to clear it off. I go to Stat, and I need to hit Edit. And then I have some information in my list. I can not worry about list 2. Let's go to list 1, hover over the top, and hit Clear, Enter. And now I need to enter my data. So I'm just typing them in and hitting Enter. 35, 10, 14, 28, 20, 23, and 10. So notice there are 7 numbers in my list, and what I need to do is calculate the mean. So I'm going to hit Second, Quit, and I want to hit Stat, and I want to go to Calculate. Calculate our variable stat, so that's number 1, and our information is in list 1. So go ahead and hit second 1, and there's our X bar. So our X bar is 20, so our mean is 20, and our standard deviation, we're looking for the sign here, and we're looking at 8.73. And I actually rounded this to 9. So we have to fill in this chart. So our X bar is 20. So if we add 1, we get 29. Add 1, we get 38. Subtract 9, and we get 11. And here we get a 2. And then over here we get a negative 7. So technically nothing should happen. You shouldn't have a negative number in your score. And then this over here should be 47. On to the next page. This is going to be part of your homework. So we need to get our graphing calculator, calculate the mean and standard deviation. So I'm going to create a table just to make organizing a little easier. Going to my graphing calculator, I'm clearing this off. I'm going to hit Stat, Edit, and I need to clear out a list. I'm going to clear out both lists. I'm hitting Clear, Enter. Go over, hit Clear, Enter. And I'm going to enter both data sets in at the same time. So for data set number 1, make sure you notice that this is set number 1, so don't include the 1 in there, and this is data set number 2. So on my calculator, I have 4, 8, 5, 12, 3, 9, 5, 2. So I should have 8 numbers. Go over to list 2, 5, 9, 11, 4, 6, 11, 2, 7. So again, 8 numbers in my list. So I'm going second quit. So I want to calculate my variable stat. So I hit Stat, Calculate, and then you hit Enter. And then I want to do list 1 first. And I'm looking for my X bar and my standard deviation. So I see 6 and 3.16. Now I want to do my second data set, and I already typed it in, so then I'm going to hit Stat, Calculate, and I want variable stats, and now my data is in list 2. So I have to hit second 2 for my list 2. And then I get an X bar of 6.88 and standard deviation of 3.06. The second question says which data set has a greater standard deviation, so that means number 1. So that means that the data is going to be more spread out, whereas a smaller standard deviation, the data is more close together. Number 2, again, we need to enter the data into our calculator, so clear, hit Stat, Edit, and we need to delete our list. So clear, Enter, delete our list, clear, Enter. So I need to type them in, 102, 98, 103, 86, 101, 110. Go over, list 2, 90, 89, 100, 97, 102, 97. Second, quit. Stat, calculate, variable stat. I'm going to do list 1 first, and you should be getting an X bar of 100 and a standard deviation of 7.23. Try number 2. So remember, today we're looking at dispersion, which means variation, variability, or spread in the data. So what does a large standard deviation mean? Spread out value. What does a small standard deviation mean? Close values. If many data values are close to the mean, what would be true about our standard deviation? Would it be small or large? Our data variation would be small. Our standard deviation would be small.